Welcome to eMath. So today we are looking at systems of linear equations, section 3.4. So you will notice that I haven't posted any video for 3.3. That's because 3.3 is just sketching the graphs of quadratic functions that we did in 2.5, right? We did that already in 2.5, so I felt like not repeating it again. So for questions on 2.3, 2.3.3, just refer to the video of section 2.5, all right? Okay, so 3.4 is all about systems of linear equations. So a system of linear equations typically is just a set of two or more equations in two or more variables, all right? So in this module, we will focus on linear equations, two equations with two variables and three equations in three variables. This is going to be our focus. We won't go beyond three equations in three variables, all right? So this is a typical example of a system of two variables, and this is a typical example of a system of three variables. Now, in order for an equation to be solvable explicitly, the number of equations must be equal to the number of variables, all right? If not, the equation cannot be solvable explicitly. The number of equations in the system must be equal to the number of variables. All right, so when you solve a linear equation, the equation can either have a unique solution, right? Any system of linear equation can either have a unique solution. Okay, that's one solution. X equals something, Y equals something, Z equals something. Unique solution. Or it can have a no solution, or it can have infinitely many solutions. Infinitely many solutions. All right, these are the three scenarios you can get when you solve a linear equation for X. It's either a unique solution, no solution, or infinitely many solutions. So we are going to look at these different scenarios. So I would like to start with the case of a system that has a unique solution. All right, a unique solution. For instance, this system here. So let's start with 2 by 2 systems. So this system is x plus 4y equals 3, 3x plus 2y equals minus 5, x plus 4y equals 3, 3x plus 2y equals minus 5. So there are two basic methods for solving simultaneous linear equations like these, all right? Either you solve by the elimination method or the substitution method. Elimination method, where you eliminate one of the variables and solve for the other first, or the substitution method, where you solve one in terms of the other, then substitute back into the original equation. Substitution method. Okay, these are the two methods we will be using. Okay, let's look at this first example using the elimination method. Right? So using the elimination method, the method involves eliminating one variable, then obtaining a resulting linear equation, all right? Solve that linear equation for the given variable, then substitute back into any one of the originals to solve the other variable, all right? In order to eliminate one variable, you need to add or subtract the two equations depending on their signs, the signs of the coefficients of these variables. All right. And for that elimination to happen, the variable you are trying to eliminate, their coefficients must be the same in both equations. Okay, so if we decide to eliminate x here in these two equations, we want to eliminate x, then the coefficient of x here is 3 and the coefficient of x here is 1. We need to make them the same. All right, by multiplying equation 1, we can call this our equation 1 and this one our equation 2. So if you take 3 times equation 1, right, then you get 3x plus 12y equals 9, right, as my equation 3. And then I just multiply 1 times equation 2. Okay, so I take the coefficient of this one, multiply this equation, the entire equation, each term in the equation. Then I take the coefficient of this one, multiply each term in this equation to make these two coefficients the same, basically. All right. So the coefficient of x here is 1. 1 times all of this times equation 2, we get 3x plus 2y equals minus 5. Equation 4. Okay. Now the coefficients of x in both equations are the same. I can then eliminate x by subtracting the two equations. Look at it. If I add, I don't eliminate x. All right. It will be 3x plus 3x, which is 6x. I'm looking for a way to eliminate. So the only way is to subtract, so that 3x minus 3x will be 0 and x will disappear from the scene, which is what we want. We eliminate it. So equation 3 minus equation 4 will give me, all right, equation 3 minus equation 4 will give me 3x minus 3x. So I'm adding and I'm subtracting like terms here, all right? 3x minus 3x will be 0. 12y minus 2y will be 10y. And then equals 9 minus 5, right? 9 minus 5, which is 14. Then we have this linear equation that we can easily solve for y. Okay, divide both sides by 10. 10 cancels, y equals 14 over 10. Which can simplify to 7 over 5, basically, right? Now, take my value for y, substitute it in any one of these original equations, and solve for x. Okay, so if we substitute, y is 7 over 5, all right? So substitute y equals 7 over 5 in equation 1. We get, what was our equation 1? X plus 4y equals 3. X plus 4 times y is 7 over 5, equals 3. Then we have this linear equation again. This is 5, not 1. Okay, to solve for x, x plus 4 times 7, 28 over 5 equals 3. X is 3 minus 28 over 5, okay, which is 3 times 5 is 15 minus 28 over 5. Okay, quickly get your calculator and do that. 35 minus 15, sorry. 15 minus 28 is negative 13 over 5. Okay, so our solution xy is negative 13 over 5, 7 over 5 system, basically. All right, so that's it by elimination method. Now let's look at how to solve this same problem by our substitution method. Let's look at how to solve the same by substitution method. So by substitution method, okay, that was it by elimination. By substitution, our question is x plus 4y equals 3 and 3x minus 2y equals minus 5. Okay, so by substitution, what you need to do is to solve for x or y in any one of these equations and substitute that value into the other one. So from equation 1, if we solve for x in equation 1, right, x will be, isolating x in equation 1, 3 minus 4y. Okay, let's call this equation 3. Now substitute equation 3 into equation 2. We get 3 times 3x, where our x is now this, right? 3 minus 4y, we're substituting, minus 2y, this minus 2y here, equals minus 5. All right? Then we have this linear equation in y that we can open up the brackets, add and subtract like terms, and solve for y. So opening up our brackets, we get 3 times 3 is 9, minus 3 times negative 4y is negative 12y, minus this 2y here equals negative 5. Adding like terms, minus 12y minus 2y, we get a 9 minus 14y equals negative 5. We now solve for y. Move the 9 to this side by subtracting 9 on both sides. Minus 14y will be equal to minus 5 minus 9, right? Which is actually equal to, what's 5 plus 9 minus 14. Then we divide both sides by minus 14 to get our y, so that y is 1, right? In the substitution method. So y is 1. Take your y equals 1, substitute it back into the expression for x, get your value for x. So our x is 3 minus 4y, right? X was equal to 3 minus 4y, and y has been obtained to be 1. So therefore, x is 3 minus 4 times 1, which is 3 minus 4, which is negative 1. So our solutions, x equals negative 1, y equals 1 for the system, right? So that's how you go about it by the substitution method. But I prefer the elimination method because I believe it is shorter than the substitution method. Let's take one more example of the two-dimensional systems. So we have question 3 here of problems 3.4. Question 3 says x plus 2y equals 1 and 2x plus 3y. X plus 2y equals 1 and then 2x plus 3y equals, okay, this is 0 and this is 1. Okay, and we want to solve this for x. So if I'm to use my elimination method, by elimination, I want to eliminate x. So I multiply this equation by the coefficient of x in this one. Equation 1, equation 2. So I'm going to do equation 1 times 2. And I'm going to do equation 2 times 1. And what do I get? For this one, I get 2x plus 4y equals 0 to get my equation 3. And for the next one, I get 2x plus 3y equals 1, get my equation 4. Now my coefficients of the x's are the same. I can subtract equation 3 minus equation 4 to eliminate x. 2x minus 2x is 0. And then 4y minus 3y is y, equals 0 minus 1 is negative 1. So straight away from my subtraction, I get my value for y. Y equals minus 1. All right. And then I bring my value for y, substitute it into any of these equations, equation 1 for instance, to get x. So 2x plus 4 times y, which is negative 1, equals 0. So 2x minus 4 equals 0. 2x is 4. Moving the 4 to that side, dividing both sides by 2, and x is 2. So my solution, x equals 2, y equals negative 1. The system. By the elimination method, all right? You can also equally do it by substitution, right? So if we are to do it by substitution, now substitution. Now in the assessment, you are not expected to do both methods, all right? You are expected to choose one. So we will never specify that you use elimination or use substitution. It will just be said that you should solve the system. Then you choose which method you are comfortable with and use to solve your system. So I'm just doing both methods because I'm illustrating so that those who prefer substitution can focus on substitution, and those who prefer elimination can also focus on elimination. Okay, so we want to use the substitution method to solve that same problem. X plus 2y equals 0. All right. So from equation 2, you can choose any one, right? Equation 2 just looks simpler to me. From equation 2, x is minus 2y. All right. Call this equation 3. Substitute equation 3 into equation 1. All right. So remember that if you use equation 2 in solving for your x, you can't substitute back into equation 2. You must substitute into the one that you haven't used yet. All right. You must substitute into the one you haven't used yet. So if we substitute this x equals minus 2y into equation 1, we get 2 times x, 2x, but our x is minus 2y. So we substitute, plus 3y equals 1. So this is minus 4y plus 3y equals 1. That's minus y equals 1, and y equals minus 1. Right. Take our value for y equals minus 1, bring it into the expression for x in terms of y, and get an explicit value for x. All right. So x is minus 2y. So y is minus 1, minus 2 times minus 1, which is 2. So our solution is x equals 2, y equals minus 1 for the system. By the substitution method, which is the same solution we got for the elimination method. Okay, so that's that for solving two-dimensional systems. Now let us look at solving of three-dimensional systems now. Okay, three-dimensional systems, for instance, the system 2x plus y plus 6z equals 3. This is question 15 of problem 3.4. X minus y plus z equals 1. And 3x plus 2y minus 2z equals 2. Now, when solving three-dimensional systems, what you must do is to, if you are using the elimination method, eliminate one variable from any two of the equations, right? For instance, looking at this, I can see that if I add up these two equations, I will eliminate y and get one equation in x and z only. Then I can use these two equations to eliminate y as well and get another equation in x and z. So I will now have two equations in two variables. Use the method we just saw for two-dimensional equations. Solve for those two variables, bring them and substitute them into any one of these originals to get the third variable. All right. So I look at these equations. If I want to eliminate, I need coefficients to be the same. So for these two, 1 and -1, if I add them up, y will disappear. So I can start by saying equation 1 plus equation 2, right, will give me 2x plus x is 3x, negative y plus y, or y plus negative y is 0, 6z plus z is 7z equals 3 plus 1 is 4. So I get this equation 4. Then I take any other two again and eliminate the same variable. I've eliminated y to get this equation. So I need to eliminate y again. All right. So I look at these two and I cannot use these same two because I'll get the same equation. It won't make any sense. I can either use equation 1 and 3 now or 2 and 3. I can't use 1 and 2 again. All right. Now, looking at these, I can make the coefficient of multiply equation 2 by 2, all right? Multiply equation 2 by 2 so that these coefficients can be able to add up and disappear. So if I multiply equation 2 by 2, so equation 2 times equation 2 plus equation 3, basically, right? Multiply this guy by 2, then add this one to it. Okay. So what do? Multiplying this by 2, we get to equation 2 plus equation 3, we get 2 times x is 2x plus 3x is 5x. 2 times -2 minus y is minus 2y plus 2y is 0. Right? Minus 2y plus 2y is 0. So the y's disappear, which is what I want. 2 times z is 2z plus minus 2z is also 0. Okay, so coincidentally, the z's also disappear. Remember, we are adding 2z plus minus 2z is like 2z minus 2z, which is 0. So I'm left with just 5x equals 2 times 1 is 2 minus or plus 2, which is 4. That's my equation 5. So I have this is z, sorry. I have these two equations to then solve simultaneously for x and z. Okay, so from 5 now, from 5, you see that I can quickly solve for z from 5. From 5, z is 4 over 5, right? Z is 4 over 5 from 5. Take my value for z, substitute it in here. Remember, I'm solving these two simultaneously. So I'm just using substitution method on these two. Solve for z here first. I get z equals 4 over 5. Substitute it into this one to get x. Okay. So substitute, write this properly. Substitute Z equals 4 over 5 into equation 4. We get, substitute Z equals 4 over 5 into 4. We get 3 times 3x plus 7 times 4 over 5 equals 4, which means that 3x plus 7 times 4 over 5. Okay, let's just do it by the corner there. 3x plus 28 over 5 equals 4. 3x equals 4 minus 28 over 5. 3x equals negative, so you can calculate that with your calculator, 8 over 5. Then divide both sides by 3, 8 over 5. Divide by 3, both sides, x equals negative 8 over 15. Okay, so we now have values for x and z. We can bring them into any one of these 3 original equations to solve for y. All right, so x is 4 over 5, z is 4 over 5, and x is negative 8 over 5. X is negative 8 over 5, z is 4 over 5. So substitute x equals negative 8 over 5 and z equals 4 over 5 in equation 1. All right, substitute that in equation 1. We get 2x, equation 1 was 2x plus 4y, or plus y. Equation 1 was 2x plus y plus 6z equals 3. So if we substitute, we get 2 times negative 8 over 5 plus y plus 6 times 4 over 5 equals 3. Okay, so this is a linear equation in y to solve for y and get our answer. So this becomes y is equals to 3 minus, this results to negative 16 over 5. So 3 plus 16 over 5 minus, this becomes 6 times 4, 24 over 5. Okay, then you can add up all of this with your calculator and get a value for y. So we have our x there, our z, and our y. That's the solution of our system. Okay, so this method goes exactly the same way. So that was the elimination method for solving 3 by 3. If you want to use the substitution method, what you would do is so 2x plus 4 plus y plus 6z equals 3. X minus y plus 4z equals 1. And 3x plus 2y minus 2z equals 2. So by the substitution method, right? Solving by substitution method, what you will do is to solve for x in any one of this. Okay, so from equation 1 or from 2, because I'm looking at 2 and x doesn't, its coefficient is 1, it's easy to solve for x in 2. You can decide to solve it in 3 or 1, doesn't matter. From 2, x is equal to 1 plus y minus 4z. All right. Now take this value for x, call it equation 3, substitute it in 1 and 3. Remember, you have already used 2 to find x. Substitute 3 in equation 1 and 2, right? So if we substitute 3 in 1 and 2, what do we get? In 1, we get 2 times x, where x is this, 1 plus y minus 4z plus y plus 6z equals 3. And we also, if we substitute into 3, this is equation 4, sorry. Substitute 4 in 1 and 3. Get confused. Okay, so if we substitute it into 3 as well, we get 3 times x. X is 1 plus y minus 4z plus 2y minus 2z equals 2. So we now have these equations 5 and 6, all right, in y and z only to solve. You can solve it also using either substitution or elimination for y and z. This is now 2 equations, 2 unknowns. We solve it the way we saw how to solve 2 equations in 2 unknowns. Take your values for y and z, bring them and substitute them into any one of these originals to get x, or just take your values for y and z and substitute them into the expression for x here. Yeah. Solve these 2 linear equations for y and z. Okay, so we can expand them as, so equation 5 will become 2 times 1 is 2. There's no space. So it's 2. Equation 5 will become 2 plus 2y minus 8z plus y plus 6z equals 3 plus y plus 6z equals 3, which is at like terms, all right? 2y plus y is 3y. Negative 8z plus 6z is negative 2z. Then move the 2 to that side. 3 minus 2 is 1. So that will be my original equation 5. All right. Then I rearrange equation 6 as well. 3 minus 3 times y, 3y. 3 times negative 4 minus 12z. 3 plus 3y minus 12z. So it will be 3 plus 3y minus 12z. And then plus 2y minus 2z equals 2. Plus 2y minus 2z equals 2. So we add like terms. 3y plus 2y is 5y. And then negative 12z minus 2z is minus 14z equals, move the 3 to that side, we get a minus 1. That's my equation 6. Okay, so equation 5 and 6 are now 2 equations, simultaneous equations in 2 unknowns, which is easy to solve for y and z. Once you solve for your y and z in equations 5 and 6, bring your y and z and substitute them here, y and z, and add up everything and get a value for x. All right, that's how 3-dimensional equations are solved. So I'll see you in the next video where I'll explain what happens with equations that have infinitely many solutions or no solutions. Thank you.